Okay, so the first thing we need in order to do XML serialization or deserialization is a set of instructions for how this stuff is supposed to work. Now, we could write instructions in every single piece of code that's ever going to use a customer object. Most of you know how I feel about rewriting code. No. Also, we have a little bit of a glitch in that, in our consideration. What if we are probably not with our customer data, but what if we're sharing data with our business partners? What if we're sharing objects with our business partners, or we need to share objects for some reason across some sort of internal firewalls or internal limitations? Multi-systems, multiple networks that are grouped together, multiple virtual boxes, multiple hard boxes. We may have to move our objects around a lot. And if we're using XML to do that, we don't want to have to write the rules for serialization in a bunch of places. We don't want to have to write the rules for deserialization in a bunch of places. We want to write it once and let everybody use it. So what we have, or what we will have, is helper code. Helper code. Okay, now we've talked a little bit about naming conventions. The way we're going to do this, I'm just going to open up a blank here. Oh, sorry, that's not what I meant. And I'm going to, before I do anything else, I'm going to do a save as, because I want to show you how this works. We're talking about customer objects, so it's customers with an S. Okay, anytime you see that S, anytime you see a plural noun, helper code does not describe an object type. It is to be used with object types. In this case, it says customers with an S. So we can assume that this is helper code to be used with the customer class. Okay, so obviously we are going to start with a block comment because, you know, block comments. Customers.java. This is code to manage XML serialization and deserialization. I will shortcut that later, but we'll spell it all out right now. This code contains the rules for generating the XML schema for the customer class. Now, schema is just a big word that means plan. It's our formal term and we like it, but it just means plan. So we're not actually going to write the schema inside this code. We're not going to write the plan for serializing and deserializing inside the code. This is actually a benefit both in maintenance and in security. If I don't have the plan written down somewhere, it's going to be a lot harder for a hacker to find. It'll be harder for a hacker to deduce. It's also going to mean that if I have to maintain my customer class, oh wait, I have to add an instance variable. Oh wait, I have to alter this instance variable. Great, fine, do it. You don't have to rewrite your XML schema. So this is actually an advantage in a number of ways, but it takes us 2 or 3 steps away from the schema. That's where the complication gets in. You're several steps away from actually seeing what your schema looks like. And that makes it a little bit difficult sometimes. This is actually going to be really short code because all we have to do is provide some pointers to Java on how to figure out how to build that schema. And the schema will exist during serialization, then it goes away. The schema will exist during the moment when we deserialize, and then it goes away. That in itself, as I mentioned, is a security advantage. That's kind of nice. But again, it puts us several steps, several points away from the schema itself, and sometimes it's hard to conceptualize without that. We need some imports. So this is my import for XML annotations. We're only going to use one. I'm taking a slightly simpler road this way in the videos than I would in a face-to-face lecture. Import. Be very careful with this. JAVAX. JAVAX stands for Java XML dot XML dot bind dot annotation dot, and this looks a little funky, but it does follow our camel casing. Capital XML, capital E, element, semicolon. Okay, so annotations. For those of y'all that use, I'm just going to type it in here as an example. At, override, those sorts of things, those are annotations. This particular type of annotation we use when we're generating Java docs. What we're going to do here is just a different sort of annotation. If you want to find out more about this, excuse me, this is in the API. XML element, XML elements with an S, the plural. That one's not helper code. I know it makes things a little confusing when there are exceptions to the rule. This is going to be the description of how our annotation is formatted, what it works, how it works, and what it means to Java when we use it. Now we've got a couple more imports. And I don't want to worry too much about these right now. This is chapter 16 material. You're getting a look at it a little early. Generic collections. We need these for some of the other stuff we're going to do in here. I'm not really going to talk about these classes. Well, one's a class and one's an interface. I'm not really going to talk about these right now. This is sort of a take it on faith for the moment and we'll fill in the blanks later arrangement. So import Java util capital L list, import Java util array list. Okay. We're going to use those, but we don't really want to dig into what we're doing. Of course, we need a correctly written class header. Please make sure you get that S in there, that this is plural. Please don't forget that. We will have much grief if that is forgotten. Now, literally, there are only three pieces, three very, very short pieces to what we need to do in here. The first one is the part that's actually going to help Java work out what the schema needs to look like. So this is our annotation. Annotation to Java for creation of the XML schema. It's just one line, at XML element, open paren, close paren. Now, right this second, I have my hands off the keyboard. Take your hands off your keyboard if you're playing along. This is not a Java statement. You don't put a semicolon after your at override, do you? This is not a Java statement. We do not put a semicolon after this. And I'm going to actually add this. No semicolon. Not a Java statement. Yes, I know my comments get shouty. We are going to have to pass a couple of things to that annotation. The two things we're going to pass, we have to, yes, two of them. We are going to pass them as arguments, but these are very different from our Java arguments. Up to this point, all the arguments we've been working with in Java have been positional. Argument 1 followed by argument 2 followed by argument 3. This is different. For the annotations, because we're literally taking this out to an XML engine, and it speaks a different language. Java's going to do all the heavy lifting for us, but that engine speaks a different language, and this is where we have to do a little translation so that Java can talk to that engine a little more effectively. These are what we call named parameters or arguments. I'm going to use type first. Because they're named, you can put them in any order you like. I like my type first. Type equals capital C customer, and this part is really important, dot class. Dot class, not dot Java. No dot Java here. Dot class. What we are actually sending to the XML engine is a copy of the executable description of our customer objects. So this has to be class. Okay, the second argument we're going to pass, and I'm going to put this all on one line, name equals, and this must be a string, so quote, I'm going to use customer, and then I'm going to pull my comment back so it's all on the line. Typically, we use our class name here, the name of the object type we're going to serialize, but we lowercase it because it's not the descriptor code. Okay, one customer, not a description of all customers ever, everywhere. One customer. This is effectively going to become our tag in our XML. Okay, now you can watch this for a moment, and so I can get some more comments in. I'm going to add a little bit here. This must be our executable code. And this is our XML tag for a single object in the XML document. Okay, so that's going over that again. That's our first piece. Yes, I know, you have to watch where the cursor keeps trying to put you because there was no semicolon. Dr. Java keeps trying to say, no, this must be a continuation. It's not. We're done with that. We're done with that. What we're going to do here is declare a holding container for customer objects being serialized or deserialized. So we're going to be talking about a bunch of customer objects. We're we're going to be talking about groups, right? So we need a place to put our stuff. We need a place to put our stuff while we're getting ready to serialize them. We need a place to put our stuff when we're done deserializing. So that's what this is. This is a place to put our stuff. This is harking back to those imports I told you we weren't going to talk too much about. Okay, so please be careful. Copy this the way I'm typing it. Private, always private, please, always private. If we don't use the basic security that Java gives us, there's no point in using any security. So we're going to use this. This is going to be a private thing. List less than, and by the way, no extra spaces in this, friends. Customer greater than. We'll talk more about this in chapter 16, but Java does not like spaces around the less than and greater than when they're not being math. Remember I mentioned these are effectively our half guillemets, or formally our half guillemets. You can call them tag symbols. I'm fine with that. But between our types and our tag symbols, there can be no spaces. Java does not like that. Or at least Dr. Java doesn't like that. Space, customers, again, notice that S, and notice the lowercase c. Typically, this place to put our stuff is named the same as our helper code, but lowercased. We set that equal to and call a constructor. The constructor call is for array list, less than, customer, greater than, open paren, close paren, semicolon. Okay. Again, in this portion, no extra spaces. I guess you might be able to, you should be able to after the greater than sign, but where we have our types and our tag symbols, no spaces in there. And of course, you know me, I put a space inside those parentheses. So that's just going to give us a place to put our stuff. We just need a place to put our stuff. It's just a bag, a box, a bucket, however you like to envision it. It's just a place to put our stuff. However, it is a private place to put our stuff. So it lives here. It won't live anywhere else unless we let somebody take a look at it. We know how to do that. That's called an accessor method, remember? So we will write one accessor method here. This will be a public method. It returns a list of type customer. That's what that series of symbols and types means. And just like every other accessor method we've ever written, get customers with an S, plural. It accepts no arguments. Let me scroll up and get some space there. This is how we're going to allow access to our bag or our bucket of customers. Okay, when we do our serialization, we'll put them in here. And when we do our deserialization, we'll grab them out of here. And this is the way we get to it, to do whatever we need to do. Very simple, just like every other one of our accessors, if I can type correctly. Return customers. Okay. Oh, and I forgot my block comment. How did that happen? So, the following method provides access to the collection of customer objects during serialization or deserialization. Okay, and it is just an accessor method. So part 1 was our annotation. That's the first thing we did. Part 2 was simply creating a place for our stuff, a bucket, a bag, a box to put our stuff in. And part 3 is providing a way to get to the bag or box or bucket of stuff. We created it up here. Thank you. We created it up here, but we're going to have to let the process, whatever process is using this, get access to that. And this accessor method is the means for doing that. This is really pretty simple code. It's just that we've compressed so much into those few little lines. So much is going on in that I wanted to walk through this with you guys at a fairly slow pace and kind of explain all the bits and pieces. Now, here's the fun part. I'm going to compile that and see if I've got any typos. Oh, awesome. Some days it works. Okay. I will include executable code for this later in the demos as needed, but I want you to write this code for yourself. Okay, please write this code. You need the practice going through it. You need to think about it. If you're typing it and thinking about it while you're doing so, it will help lock down some of the concepts a little more firmly. Okay, that's this piece. Yes, we do have more to come. Thank you.